Okay, so let's do it. Okay, so data mining has its roots on three families. Okay, so it is based on AI, okay, machine learning, and also classical statistics. Okay, the application of data mining was seen to have been successfully used from 1990, but its history is further early. Okay, actually data mining is like one of the machine learning approach, okay, to handle big data. Okay, methods of identifying data patterns were discovered in the early 70s, okay, 1700s and 1000. Okay, when the Bayes theorem and the regression analysis was first discovered and used. Okay, so for Bayesian and regression analysis, okay, usually we cannot solve it manually. Okay, we cannot solve it manually. Okay, because the data dimension is big. Okay, so that's why we need data mining. Okay, the Bayes theorem was used to find the probability when other probabilities were available. Okay, so for Bayesian, okay, I explain a bit about Bayesian. Okay, for Bayesian, okay, we are going to find the posterior probability. This one, Bayesian. Okay, we're going to find the posterior probability by first, okay, find the probability when the other probabilities were available, okay, which is equal to, okay, what is the probability when other probabilities were available? It's the prior, okay, it's a prior probability, which, okay, times with the likelihood probability. Okay, so that this is the information, okay, that we know earlier, okay, before we conduct this, and times with the likelihood probability. So what is the type of what is the type of analysis, okay, that you're going to carry out? Okay, and this is Bayesian. Okay, regression analysis is a purpose of estimating the relationship between an outcome variable. Okay, regression analysis process of estimating the relationship between an outcome variable, which is dependent variable, and either one or more dependent variable. Okay, regression is basically, okay, you know that you learn in mathematics, y is equal to mx plus c, right? Okay, mx plus c, so which means that it is linear, right? Like this. So y is equal to mx plus c. Okay, in statistics, we also have this kind of things. Okay, but instead of that, okay, we will have our variable as y, okay, as the independent, okay, and x as the dependent. So this one is dependent variable. Sorry. Okay, and x is the independent variable. Okay, so this one, if we have one dependent variable, y equal to mx plus c. Okay, in statistics, we can have more x, so which means y equal to, okay, c I replace it with alpha plus b1x plus b2 beta 2x beta 1 x1 beta 2 x2 plus, okay, how many beta? Maybe beta n xn plus error term. Okay, plus error term. So this one also, okay, you see that we have many x, x1, x2, x until xn. Okay, so in order for us to find and calculate this equation, okay, it's hard to calculate it manually. You can, but it's hard. Okay, especially you have a big dimension of data. So that's why we use data mining. Okay, as the data sets grew in size and complexity, okay, the ubiquity and computing power of computer technology also increased, thus leading to the rise of data mining. Okay, so which means that once, okay, we have like big data, okay, once we have a big data dimension, so we favor to use data mining. Okay. And okay, data mining is the process, of extracting data from a large data set, analyzing, discovering the patterns to help organizations to solve problem discoveries and take advantage of new opportunities. Okay, like in regression, okay, we get the data, then we run the regression. Okay, we get the data. Okay, then we run the analysis regression. Okay, then we get the equation of the regression, right? Okay, from this equation, okay, we can find any conclusion. Okay, so okay, like in prior in Bayes theorem, also the same thing. Okay, we get the data, we run the analysis, get it again. But for the Bayes theorem, we get the probability, then we find the conclusion. Okay, so this one is for regression. Okay, so it involves the use of artificial intelligence, machine learning, statistics, and database technology. Okay, usually data mining used by a business organization to answer questions that were previously time-consuming and tedious. Okay, time-consuming and tedious. So rather than you do it manually, okay, so we can use data mining, okay, to formulate all this. Okay, and computer technology advanced data has had a systematic way of being stored in database. Okay, the rise of machine learning, where computers can receive and understand instruction, and artificial intelligence, where machine can execute the task without the help of humans. Okay, it has led the use of data mining in the organization. Okay, data mining involves use of algorithm that can go through a large set of data in a database and find the required information within a small period. Okay, I think for your final assessment, okay, I will do a bit of like small project. Okay, not just essay, small project that you have to use. Okay, I think Excel should be suffice. Okay, that you use Excel or any programming language. Okay, to do a simple project. Okay, I will give you the data, then you have to run it. Okay, of course, I will supply some of the video on how to do the on how to use Excel or how to use other software that I'm going to specify. Okay, to run the analysis. Okay, so what is the advantage of data mining? Okay, so the advantage of data mining is, okay, it should be very fast because it has speedy process of extracting and analyzing data. Okay, and it can forecast market trends. Okay, it's for data mining. Okay, you just not keep the data, but okay, you can also forecast, okay, the market trend. So we can see, okay, what we're going to be in the next 6 months, something like that. Okay, so it helps the research and development department find the correct trends in the market through research by choosing the right market strategies. Okay, so let's say we know about the forecast. Okay, maybe forecast shows that, okay, the next 6 months, the sale is not favorable. So, okay, the business can be advised that we have to slow down the production, something like that. Okay, and maybe we can change the trend, okay, according based on the consumer's preferences or product. Third advantage is proper decision making. Okay, it helps the organization conduct market research that will allow the organization leadership to make knowledge-based decisions that will be vital to the success of the organization. Okay, so let's say we can do, maybe we want to like launch a new product. We can do like a survey, okay, among the consumer so that we can understand the trend. Okay, and customer relationship management. Okay, we can conduct market research using data mining technique. Okay, the customer's demographic, tastes, and preferences. Okay, this will ensure that the organization products are in line with the required specification. Okay, another benefit is we can accurate anomaly detection. What is anomaly detection? It's like we can estimate the outlier. Okay, outlier. Anomaly is outlier. Okay, it can ensure that there is accurate data analysis. So which means that if we have a data that is, okay, that is like very different, okay, like very, it's outlier, it's not in, okay, it's very different, okay, we can detect it. Okay, so it can it ensure that there is accurate data analysis. Okay, this is because data mining ensure that the data is classified in order of priority. Then accurate analysis will ensure that error detection is made easy. Okay, so let's say I compile salary. Okay, uh, salary of the worker. Okay, in like Ampang area. Okay, so I can see that the salary for the Ampang worker, it will be, okay, maybe 2,000. Okay, some of the like professional earn 10,000. Okay, then suddenly one of the salary is like negative 500. Okay, so data mining, okay, we alert us that there will be outlier here. Okay, so you can make sure that we can check it. Okay, we can check it. Okay, we have two choices, whether we have to correct the data or we just discard it. Okay, so that we can carry the analysis in a proper, we can carry analysis better. Okay, third is, sorry, and next advantage is help an organization stay ahead of the competition. Okay, because we have run the analysis, okay, so the organization can compare and gather the information against the main competitors. Okay, with this information, organization can improve their marketing strategies, create a stronger brand, and develop better products and services. Okay, so which means that, okay, so after we know after we forecast, okay, after we do the survey, okay, it means that we are ahead of the competitor. Okay, which means that we can understand, okay, the trend, we can understand the outlier, okay, and we do market research frequently because of the data mining algorithm. Okay, and last is easy integration. So data mining is a process that can be implemented in existing and new system of an organization. It does not matter when a business organization started or wherever business system they have, it can be easily integrated. So which means that once the system of data mining is installed, okay, so it's not hard for us, okay, to run the analysis. Okay, any question about the data mining? Okay, I need to get a charger. Give me 1 minute. Okay, okay, now okay, so this is the advantage of the data mining. Okay, so next is, what is the disadvantage of the data mining? Sorry, it's lagging a bit. It's lagging. Okay. Okay, so what is the disadvantage? Okay, so the first disadvantage is, okay, the privacy violation. Okay, market-based technique used by data mining to gather data does not respect the institution of data violation. Okay, so organizations use data they have gathered from their consumers and trade it with other information, and this method of gathering information is considered ethical. Okay, so okay, we know that the Data Protection Act, okay, sometimes, okay, we just grab the information without, okay, the consumer concern. Okay, so that's exists the user privacy violation. Okay, so they use the data, okay, and to get the information for the market research. Okay, so this is one of the disadvantage of data mining. Okay, and data mining also has the advantage to expensive to start. Okay, before we set up with the data mining system, okay, in the organization, so we require a lot of resources to start and run the process. So we to have enough storage resources. Okay, a trained specialist that will run the process and other resources to maintain the process. So which means that we need to have an expert to advise us on how to use the system, and someone who can maintain the system if anything happen. Okay, if you want to make any query. Okay, and another one is to install the like that to install the data warehouse, because once you have a data mining, you have to install a data warehouse. Then after that, you can use it for analysis, right? Okay, so you have to have a database you have to have someone for that to keep for your data, which is database manager. Okay, and after that, you have to have someone, okay, that is expert in data mining, okay, that will help you to run the analysis. So which means that we need a lot of person in charge, okay, in order for us to start with the to implement data mining. Okay, and third is need for technical know-how. Okay, data mining and analytic software tend to be difficult to operate. Okay, for the first time that we are going to initiate the data mining, okay, is quite difficult, especially for those who are not familiar with the function, okay, with the programming language. Okay, so we have to employ a person with prior training, okay, on how to operate the software to run the process of data mining. Like I said, we need someone who who is expert in all that. Okay. The next disadvantage is for the data security. Okay, an organization that runs the data mining process store large numbers of important and personal information of its customer. So if the data is leaked to the public without consent, they may have adverse effect on organization and individual. Okay, the risk of the organization being hacked raised a lot of concern on the security of an individual's data. Okay, so which means that, okay, because we keep, okay, data, we have a data warehouse, okay, and we have a database we have a database, okay, which means that we have to spend more, okay, on the data security, because we don't want our data to leak to other competitor, and we don't want our data, okay, to be leaked to the public, because it is like our organization kind of secret. Okay, so we also have to spend on data security. And the last disadvantage, which I think is not that, okay, it's not like important to highlight, is inaccuracy of data, because we deal with big data. So data mining analyze the data without necessarily knowing the meaning of the data. Okay, visualization can only be done by the user, and sometimes the data mining process may lead to inconclusive result, but this result may bear serious consequences on the organization decision. The inaccuracy of data means, okay, sometimes, okay, maybe you are selecting the wrong model, and sometimes, okay, you just run it without checking the data. So I think this one can be a lesson. This disadvantage can be avoided. Okay, can be avoided if you check before you run it. You check the data. You do the data cleaning. You do the data check. Okay, check for the outliers. Check for this, for that. Okay, check the domain and everything. Okay, so this one is actually you can avoid it. Okay, so because data mining is a like powerful tool to help us in statistical, forecasting, and other analysis. Okay. So, okay, important data mining primitive. Okay, I don't know why they use the word primitive. Actually, important data mining and their function. Okay, primitive is actually a function. Okay. Okay, so okay, so basically, okay, data mining is divided into two parts. Okay, which is the predictive, where we run the predictive analysis, and also descriptive. Okay. Okay. So for predictive, okay, we have classification. Okay, what is classification? Okay, I will later explain. And regression. Okay, we can have a forecasting, or what is a time series analysis. Okay, and we can also have like probability prediction. Okay, for descriptive, okay, data mining for descriptive analysis. Okay, we have a clustering. What is clustering? Clustering is like grouping. Okay, I will explain later. Okay, we can have a summarization. What is summarization? Summarization in descriptive is like we find what is the mean, median, mode, the standard deviation, and all that. Okay, we can know what is the frequency. Okay, what is the expected frequency. Okay, within that, we can also have an association rule. Okay, what is association? Okay, I will explain after this. And also sequential. Sequential. Okay, so this one. Okay, so data mining we run into predictive model analysis or descriptive model analysis. Okay, predictive model, okay, makes a prediction about values of data using known result from different, found from different data. Okay, predictive modeling, okay, usually we use historical data. Okay, we use historical data. Okay, like I said, like example, okay, like credit card. Okay, credit card use, okay, might be refused not because of the credit card history, but because the current purchase is similar to earlier purchase, okay, that found to be made with stolen card. Okay, so which means that, okay, we know that, okay, there's an outlier because we already have the data. So the credit card the credit card usage will be rejected because of the it was reported as the stolen card. Okay, so this one, okay, in predictive model, okay, it indicates specific type of data mining function. Okay, so whether we want to use classification, regression, forecasting, and so on. Okay, for descriptive model, okay, it identifies pattern or relationships in data. Okay, so it just like data exploration. Okay, we want to predict the data. We just want to examine the data. Okay, not like into analysis. Okay, usually we do this descriptive first before we do the predictive analysis. Okay, so descriptive is like you want to see if there any association, whether it's independent or not independent and all. Okay. Okay. So first of all, okay, so data mining primitive are activities that allows users to interact with using communication in a data mining system. Okay, so The first one is kind knowledge that is to be mined. Okay, this task will need to specify the kind of function to be performed on the data. Okay, we can have a discrimination. Okay, what is the discrimination? Discrimination is like, okay, okay, let's say discrimination is like, okay, you have we call it as discriminant analysis in statistics. Let's say you have 10 factors. Okay, you have 10 factors that influence obesity in Malaysia. Okay, you have 10 factors. So discriminant analysis, what we call as discrimination, it means that we want to know out of the 10 factors, how many actually important. Okay, so we group it. Okay, we group it. So from 10, we get like 3 groups. So this one 3, 3, and last one is 4. Okay, so we know that we have 4 discriminant group. Okay, so we run the discriminant analysis. Okay, characterization. Okay, characterization is like similar like classification actually. Okay, we want to know, okay, what is the minimum, what is the maximum of the data. Okay, and we want to see is similar like discrimination. Okay, which factor that is like the influence the most of the variable. Okay, so we want to see what factor that is significant, okay, in our analysis. Okay, clustering. Okay, clustering also similar like discrimination, which means that we want to see, okay, out of many factors, so how many factors that is related to each other. So which means that out of 10, okay, so we find out that we have a 3 cluster. Okay, we have 3 clusters. Okay, so we know that we can treat it, okay, according to the cluster group. Okay, prediction. Okay, prediction is like regression. Okay, it's like regression, which is, okay, we have a regression analysis, so we want to predict. Okay, we want to predict. Okay, if let's say we have like something like this. Y is equal to maybe okay, 24.7 plus after we run the analysis we get plus 0.3x, something like that. So we want to see, okay, for the prediction, when x is equal to 100, okay, then we can find what is our y. When x is equal to like 50, what is our y? Okay, so this is a prediction. But in order for us to get it, sorry, it's lagging. Okay, in order for us, okay, to get all the prediction value, we must use data mining to run it. Okay, F is evolution analysis. The evolution analysis is actually, prediction is like regression. Evolution analysis is actually forecasting or time series analysis, which means that if we have a data, we can estimate what happened next. Okay, what happened next 6 months, what happened like in next 10 weeks, something like that. Okay, so we can use a model, okay, we can use model, okay, in data mining to estimate what would be happen, okay, in next cycle. Okay, outlier analysis. Okay, outlier analysis, we're going to find any like we're going to find any noise or any disturbance in our data before we carry out with the predictive model. Okay, before we carry out with predictive model. So usually we discard all of the outlier analysis, or okay, we repair it and treat this as noise. Okay, next is correlation or association analysis. Okay, in order for us, okay, to run for the predictive model, we need to find any correlation or association. Okay, so we know we have, let's say we have X and Y. So X1, X2, X3, and Y. Okay, so by using correlation and association analysis, we want to see whether is there any relationship between X, Y, and Y. Is there any relationship between x2 and y? Is there any relationship between x3 and y? Okay, let's say I add more. Okay, y2. So by using association relationship, we would test. Okay, it is independent, or is there any linear relationship between x1 and y2? Okay, x2 and y2, and also x3 and y2. Okay, usually we will find a covariance. Okay, we will find standard deviation. Okay, and make other analysis. Okay, next is the task relevant data set to be mined. Okay, so the task of primitive specify the set of data or the proportion of the database that the user might be interested in. Okay, so first is database characteristic. Okay, so database characteristic is like summarization. Okay, so where we are going to find the mean, okay, median, mode, and standard deviation, and etc. And the dimension of interest of data warehouses. Okay, so we want to know how many, how big is the data, okay, that available in the data warehouse. Okay, we want to know how big is the data. Okay, whether it's like 10,000, then available with 10,000 independent or dependent. Okay, and so on. Okay, the third primitive. Okay, the third data mining primitive is prior knowledge to be used in the process discovery. Okay, the star primitive help the data mining process to be done on various levels of abstraction and is useful for evaluating patterns during the knowledge discovery process. Okay. Okay, concept hierarchy is an example of form of background knowledge. Okay, so before we run into any other analysis, okay, like you want to know the summary of the data, okay, the summary of the data, okay, the frequency of the data, maybe you want to know the percentage of the data, okay, so sometimes we put it like hierarchy of the data, okay, so we want to have a prior knowledge, okay, before we run into any analysis. Okay, apart from that, okay, another function of data mining is we can visualize it, okay, we can visualize it. Let's say we want to do like a bar chart, table, pie chart, decision tree, okay, or any row. Okay, so before we do the predictive analysis, we can see, okay, maybe we can plot a graph, okay, to see whether there is a linear relationship or not, okay, or we can have like a bar, like histogram, okay, or maybe you can have a like line graph, okay, line graph for the visualization. It's lagging. Okay, wait, hold on. It's lagging more. I write something, okay? So like bar graph, pie chart, and so on. Okay. Interestingness measure and threshold for pattern evaluation. Okay, this task primitive is used to evaluate the pattern that have been discovered or guide the mining process. Okay, so let's say, okay, we already know, okay, that the data is significant and independent, okay, which means that, okay, after we know that the descriptive part, okay, we're going to proceed with what is the next step. Okay, maybe after I got the data descriptive, okay, I believe that I can start with maybe regression. Okay, after I get the descriptive, after the descriptive, okay, I got the descriptive, okay, maybe I, okay, discovered that I should proceed my analysis with regression. Or, okay, maybe I can proceed with discriminant analysis to find how many discriminant group. Okay, maybe I can check if I have any cluster, something like that. Okay, although discriminant analysis and cluster analysis is the same, okay, it produce different, it use different formula and different method. Okay, so the result might be different. So we can have like many different view, okay, on how to analyze our data. Okay, so the data mining function, also referred to as data mining technique. Okay, this technique help the organization transform the raw data into the actionable insight. Okay, this technique. Okay, so this is like of like what is the predictive model of the data mining? Okay, what is the predictive model of the data mining? Okay, the first one, classification. Okay, what is classification? Okay, actually, oh, I already replied to you. I already like explained to you. It's okay. We go more further. Okay, this technique is used to assign data values and a data set to classes of categories. Okay, so which means that we want to assign it to classes or categories. So which means that, okay, let's say I have like obesity, okay, obesity factor. Okay, so I want to set the classes as age, okay, weight, height, fitness level. Okay, let's say another factor is maybe genetic. Okay, so for this, okay, we want to set the data set into classes or categories. Okay, so what is the weight? So we have to make sure that the weight is in numeric. Okay, and it can be in continuous. Okay, age should be numeric, but it has to be in discrete, like a round number. Okay, and genetic, this one is must be categorical data. Okay, whether what is the genetic? Okay, good. Maybe yes or no. Okay, fitness also in categorical data. Fit, not fit. Okay, or unhealthy, something like that. Okay, so classification map data into predefined group or classes. Okay, is referred as like this one. Okay, we do before we examine the data. Okay, so let's say you want another example. If you want to make a bank loan, okay, you want to make loan. Okay, we want to find the credit. Okay, let's say you want to make another example is I want to make a bank loan. Okay, so and we want to identify the credit risk. Okay, before we like off the bank offer the loan to the customer, we want to identify the credit risk, right? Okay, they want to find the credit risk. Okay, and okay, classes be defined based on data attribute values. Okay, so first is maybe we can have several classes based on predefined example. Okay, so let's say identify credit risk. Okay, we have like age. Okay, whether what is the career, okay, the salary, and whether we have like family or not, status, whether it's family, single, or like other. Okay, so this one is like the classes. Okay, the classifying classes for the data mining. Okay, so the main aim of classification is to accurately forecast the target class each case in the data. Okay, so let's say when we do these classes, so we know that, okay, when we run analysis, we find out that, oh, for obesity factor, genetic and weight is the contributing factor for the obesity level. Okay, something like that. Okay, let's say like for bank loan, so we know that career and let's say status, okay, is the contributing factor that leads to identify the credit risk. Okay, so it is easier for us to do the classification before we run the predictive model. Okay. Okay, so this is what is it? This we have a three classification technique. The first one is to record. Okay, so some of the properties of a record are class, label, and attributes. So a feature is the part of a record that is stream of the label. Okay, classification predict the class label for the feature. Okay, which means that from the record, okay, we can do the classification. Okay, another classification technique is training data. Okay, group instances with the aim of learning. For supervised learning to happen, okay, instances from data are needed to facilitate the provision of knowledge to the system, so conduct prediction of classes. Okay, so for the record, okay, it means that it's already there, so we can do the classification. Okay, for training data is, okay, we group the data, okay, randomly. Okay, we group the data randomly. Okay, we group the data randomly. Okay, so and after we get like prior knowledge, okay, after we get the prior knowledge, okay, after we get the prior knowledge, okay, maybe like for the data, let's say that weight and height is not important. Okay, so we skip it. So we only consider fitness and genetic because of the prior knowledge, okay, from previous like experiment. Okay, third is testing data. The group instance to effectively test whether the system has learned. Okay, the testing feature are only available to the algorithm only. Okay, so here we test the data, okay, based on the group that we did. Okay, so we can see whether the data mining system understand our system or not. Okay, so and after that we can do the classification effectively. Okay. Okay, so we have two main steps in classification. The first one is model building. Okay, so every object is assigned to predefined class label. So we specify, okay, what the factor for each variable, okay, and the algorithm will build the classifier and the training sets are made available for the classifier to learn. Okay, so because we have already defined, okay, what is the, let's say I said to you, this is a numeric discrete, numeric continuous. Okay, so every object is assigned to predefined class label. Okay, we already defined what is the class label. Okay, so like numeric discrete for age only accept numeric discrete, for weight also numeric continuous. We set the domain first. Okay, and also the range. Okay, next for the classification is model usage. The model is used to predict the class label and use the text data to estimate the accuracy of the classification rule. Okay, so let's say that after that, okay, let's say we not specify this at all. Okay, we have a random data. So data mining, okay, by using the algorithm, we automatically classify whether, let's say I have like 50 kg. Then after that, yes. Then after that, genetic is no. Okay, fitness, so maybe it's healthy. So let's say we have a random data like this. Okay, so by using the data mining algorithm, okay, it's automatically, after they see the domain and the unit here, say 50 kg, okay, it's automatically addressed, okay, to age, classified to age. Healthy is, which means that it's automatically addressed to fitness. Okay, and no, it's automatically addressed to genetic, because we have set the domain is know where it should, the class should be. Okay, because it has even though we have like random data, okay, we by using the algorithm, they already know which class that is belong to this by okay, after applying the model. Okay, that is the classification technique. Okay, next is clustering techniques. Okay, clustering analysis. I like clustering analysis. Okay, I did a lot of clustering analysis during my master study. Yeah, PhD study also I did it. It's very, very good for spatial analysis. Okay, clustering analysis is a technique used to find what is like for each other. Okay, groups for the groups of different data objects are divided and classified according to similarity. Okay, like I said, okay, let's say we have like 10 factors. Okay, so then from 10 factors, we narrow down to 3 clusters. Cluster 1, cluster 2, cluster 3. Something like this. Okay, so there's many type of clustering method. The first one is hierarchical. Okay, it's like connectivity-based clustering. Or second is density-based. Okay, what is hierarchical? Okay, which means that, okay, they put like 3 clusters. Okay, the clustering, so it based on the like significant. So from 10 factors, they put it into priority. Okay, the most contributing factor, second most contributing factor, fourth most contributing factor, until the last one. Okay, that is hierarchy. Okay, density-based method. Okay, so density-based method is means that, okay, it depends on the, okay, what is the probability, what is the weightage of the, okay, similar like this, okay, what is the weightage? Okay, so we cluster it according to the density. Okay, so let's say that the density in first cluster is like the most important, so we put 3. Okay, in cluster 2, we put 4, 5, 6 factors, and so on. Okay, grid-based method, okay, is similar like density. Okay, similar like density. Partitioning method also same like density, and model-based method. So, okay, for cluster, we have many model. Okay, we have many model. Okay, so it's different types, it's from formula each. Okay, so for clustering, maybe, okay, we have like for cluster analysis and for discriminant analysis. Okay, we can see that how many factors that are clustered together. Okay, and how many factors that is like how many like in cluster, how many factors that cluster together, and in discriminant, how many factors that are clustered together. Next is constraint-based method. Okay, for constraint-based method, which means that, okay, okay, we have 10 factors, right? Okay, we have 10 factors. Okay, so which means that, okay, so we have like, okay, the first cluster, okay, the probability that must put in the first cluster, okay, we put like constraint as like, it must have like passed the significance level alpha 0.05. So we see that the 10 factors, maybe factor number 4, factors number 6, and factors number 7. Okay, and then we put that the second cluster, okay, we put a constraint that it must pass the alpha level, okay, greater than 0.5, okay, greater than 0.05, but less than 0.1. So we see that cluster factor number 1, factor number 2, factor number 3 is clustered together. Okay, or we can have another cluster. Okay, we see that, okay, this is the cluster that non-significant. Okay, non-significant at all. So we see that cluster number 8, 9, and 10 is not significant. So we make it like this is constraint-based method. Okay, centroid-based method. Okay, it's not like the constraint-based method. It means that, okay, same like 10 factors. Okay, so we put like similar like constraint-based method, centroid-based method, which means that, okay, let's say that we want to cluster that, okay, the first factor, okay, the centroid base is like, we select any measure of central tendency. Let's say we want the mean to be between 0.1 until 0.5. So we put like, okay, how are the factors here? Maybe factors 2, factors 3, and factors number 2, factors number 3. Okay, let's say here, we want to find any mean that is between like 4 until 0, sorry, 0 0.5 until 0 0.6. Okay, so we put, then we classify, we cluster it, something like this. Okay, so by using the cluster analysis, the cluster technique, okay, we can, it's similar like classification, but we have a different method for this. Okay, you just have to know that classification is, okay, you have to classify the variable, but for cluster, we need like grouping. Okay, we need like grouping. Okay, okay, so clustering is similar to classification, okay, except that the groups are not predefined. Okay, like I said here, okay, we already defined age, weight, height, fitness, genetic. But for clustering, we not define it. We let the analysis do it for us. Okay, so we call it as, sometimes we call it as partitioning or segmenting the data into group that might or might not be disjoint. Okay, so okay, we also clustering also we call it as segmentation. Okay, segmentation. So it's partition into disjoint group. Okay, we call it as segment. Okay, so okay, that's all about clustering. Okay, like classification, we define the group. For clustering, we not define the group, we let the analysis do it for us. Okay, so we have like a few application of clustering. Okay, so the first one used in IT. Okay, you want to find the web that classify the web pages and document to be displayed for the information discovery. Okay, so we cluster. Okay, to classify the web pages and document to be displayed, okay, for information. So we want to know what kind of web page and okay to display. Okay, so by business, okay, used by the marketer, by the market researcher to discover and differentiate the distinct group in their customer base. Okay, this one is like, let's say, okay, you have like instant food product. Okay, so you want to see, okay, everyone like instant product, I know, okay, like Maggie, everyone like Maggie, okay, but I don't eat the instant product for like many years, okay, because first it's not healthy, but I do eat it when I'm craving for it. Okay, so we know that Maggie, so we want to know what is the this how to differentiate. Okay, everyone likes Maggie, but we want to know what factor that okay, let's say teenagers, adult, and also like a senior citizen. So we want to know what is the factor. Okay, I know everyone likes the Maggie. Okay, so we want to know what is the factor that of a Maggie that the teens like. What is the factor of Maggie that the adults like? And what is the senior? So it is like easier for us to tackle. Okay, to in launching new product. Okay, in know how many like how many percentage for the product, how much production that we have to do. Maybe the teens prefer Maggie compared to senior and adult. Okay, so our marketing is more towards teens. Okay, and we add a bit, okay, to attract the adult and senior, something like that. Okay, for teen, okay, they like social media, so we engage with a lot of influencer. We engage with a lot of like social media engagement. Okay, so something like that. Okay, another clustering application is, okay, so like pattern recognition. data analysis, image processing, and conducting market research. Okay, let's say, we want to check, we want to check the market research like this. Okay, so we want to see the pattern recognition. Okay, so how much this contribute to team, how much this contribute to the senior citizen. Okay, and other than that, also they can use it in weather, okay, for clustering analysis. We can see okay, what is the factor that will contribute to the weather condition. Okay, so by using the cluster analysis, we know that, okay, the image of the, okay, so they said that, what we call it, okay, for the next day, okay, next day to get rain, okay, it must have like 3 continuous hot, like dry period, okay, 3 continuous dry period. So which means that Monday, not rain, very hot, Tuesday, not rain, Wednesday, not rain, then on Thursday will be a heavy rain, something like that. So we see a pattern. Okay, 3 dry period followed by heavy rain. Okay, but flash flood. Usually flash flood will follow if, okay, there will be like a short rain for the 5 days. Let's say Monday, Friday, Tuesday, Wednesday, like 5 days, short rain, then followed by Saturday will be like flat, something like that. Okay, so we see a pattern recognition by using the cluster analysis. Okay, so in biological field, okay, clustering is used a lot in bioinformatics. Okay, especially in genome, plant taxonomies, okay, and structure of population. Okay, it's like my cousin is an epidemiologist, I don't know, epidemiologist. I think something like that. Okay, so okay, they use the to do like bioinformatics. Okay, so they want to see, okay, the genomes research. Okay, genome research. So genome research, they want to see. Okay, they want to like know, okay, our DNA and all. So we want to see that. Okay, for like Malay, okay, the genetic sequence is like this. Okay, so we can say that, oh, this is according to the Malay. Okay, for genetic like Chinese, okay, this is how the genetic sequence is like this. So it's Chinese, something like that. So we see the cluster. So we see that, oh, if Malay, okay, they tend to get like diabetes. What is it? The three type: diabetes, blood pressure, and kidney failure, something like that. So the genetic sequence would be like, oh, because of the lifestyle, okay, the Malays usually get this kind of disease, okay, or cancer. It's like inherit, okay. And for Chinese, the genetic sequence is like this. Usually they get, I don't know, maybe like bone something, okay. I'm not sure, okay, but I know that Malay usually have like, you call it as tiga serangkai, which is blood pressure, diabetes, and also blood pressure, diabetes, and kidney failure. Okay, it's common, especially for those who live at the west, not east side, west side of Malaysia. Pantai Timur, because they like to, coconut milk and berry, then okay, sweetened drink, okay, then everything like oily coconut, okay, so something like that, okay. So we can like use the genetic sequence, okay, in cluster analysis. Okay, so why we use cluster in data mining? Okay, so the need for highly scalable clustering algorithm that will help with large database. Okay, so we have a lot of data. Okay, so by using cluster, we can see the pattern. Okay, we can understand it. Okay, it make our conclusion more conclusive. Okay, the need for algorithm that can handle both high dimension and low dimension. So, Okay, when we have cluster, it's easy for us to handle high dimensional and also low dimensional. Okay, the need for clustering, okay, result that can be easily interpreted and comprehend. Okay, when we have a cluster, it's easy for us to find to like interpret the result. Okay, it's easy for us to interpret the result and also find a conclusion. Okay, so the need for the clustering algorithm can deal with data that contain different attributes. Okay, so let's say like my example previously, we have like data that is height, data that is like obesity categorical. Okay, so by using cluster, okay, we can have like different attributes. Okay, clustering can deal with noisy data that leads to poor results. Okay, for clustering, okay, if we have any outliers, okay, or if we have any noisy data, okay, let's say we already know that this is not significant, so we can just discard it. Okay, we can just discard it. Any question? Any question?
Doctor, hello here.
Mm.
Later on, are you able to share a practical example of this application of clustering? Maybe a real life example or quick example?
Okay. I have example of clustering, you mean?
Yes.
Okay. Let's I think I already like tell you a bit about the example of the clustering. Okay, let's say okay. Wait, let me find it. Let me find it. Okay, maybe I can find a paper. Okay, I can find a paper that use cluster analysis. Wait, let me Google now. Cluster analysis. Need to find a paper. Okay, so let's see. Okay, like retail marketing. Okay, we use okay, this one I just Google it from the internet. Okay, like for cluster analysis, like in retail marketing. Okay, like in retail marketing. Okay, so we want to identify group household that is similar to each other. Our objective is okay to find identify group. Sorry, to identify group that similar to each other. Okay, so we get the information on household. Okay, we get the information of household. Okay, so I have household income. Okay, second, if I have the household size. Third is I have the occupation of the head household. Okay, so fourth is okay, I got the distance from the nearest city. Okay, so we do a cluster. Okay, we do a cluster algorithm. Okay, then we find out that we have found 4 clusters. 1, 2, 3, 4. Okay, what is the cluster? We find out that, okay, cluster 1, okay, usually it is small family, but high spenders. Cluster 2, this one cluster 1, cluster 2, okay, we find out that it's large family, Okay, this one is low spender. Cluster 3, okay, we find that the cluster 3 is small family, low spender. Cluster 4 will be large family, low spender. Okay, sorry, this one high spender. Okay, so this one is like the cluster outcome will be. Okay, this one will be outcome will be. So the company can send personalized advertisement or marketing strategy go to each household based on how likely they are to respond to specific types of advertisement. Okay, so there we prepare 4 types of personalized advertisement. So to attract small family, maybe the marketing should be like more promote the family value, okay, but like spoiling them with a lot of like unnecessary so that they can spend more on the product, something like that. Okay, for cluster 2, different advertisement strategy. Okay, okay, this is like retail marketing example. Okay, I give you another example so that you will understand. Okay, like in sports science. Okay, like in sports science. Okay, like in sports science. Okay, so data scientists for sport team, okay, use clustering to identify players that are similar to each other. Okay, our objective of a data scientist for the sports science team, data scientist for the team, is to identify players' performance that are similar to each other. Okay, so the data for the basketball team, okay, they collect the data points that they collect per game. Okay, rebounds, like in this one is basketball. Okay, rebound they make per game. Okay, assists they make per game. Okay, and steal. Okay, steal they make per game. Okay, so they do the clustering algorithm, okay, to identify similar player, so they can have this player practice with each other. Maybe that, okay, we have 3 cluster. Okay, so the first cluster will be, okay, high score, okay, but low steal. Okay, this one may be low score, but less assists, and high, but great assists, like high assists. Okay, so they more like, so cluster 2 is more like in defense team. Okay, high score, low steal, maybe we can put as like the attack team. Okay, this one is in defense. Okay, maybe this one as like a standby, like backup. So this one is okay, maybe this one like high rebound. Okay, but also high steal, something like that. Okay, so this is an example of cluster analysis. Okay, we try to do, okay, the cluster analysis to find that what is the factor that's, okay, similar to each other. Okay, now, okay, we begin with association rule. Okay, so association rule is a technique that is used to find the association between 2 or more objects in the data set. Usually, for association, we test it by pairing. Okay. Okay, we test it by pairing. So which means that x1 and y1, x2 and y1, something like that. Okay. So it's all on pairing. Okay, usually it involves if-then statement that help find the relationship between the data set. Okay, okay, and association rule is suitable for non-numerical and categorical data that usually require more than normal counting. Okay, so for association rule, it can be like not numerical and also categorical. Okay, the main purpose of the association rule is to find patterns that occur frequently. Okay, we want to find the correlation and the association between the data sets of various database. Okay, so association rule has two parts. Okay, antecedent. Okay, usually if the if statement and the consequent for the then statement. Okay, if is for the antecedent. Okay, then is for the okay, consequent. Okay, so we have if, okay, statement and consequent for the then. Okay, the antecedent can be defined as the item that is found in a data, or the consequent that is combined with the antecedent. Okay, we have two parameters when the relationship are observed. Okay, so like I said, we test it in pair. Okay, after thorough analysis and looking for if-then statement. Okay, usually I also use if-then for my analysis, but okay, if-then usually we have to do the looping. Okay, we have to do the looping. Okay, I'm not teaching you programming, but just like tell you that it's about the looping. Okay, and okay, we have a support, okay, which is an indicator of how frequently if the if-then statement forms a relationship in database. And the confidence is an indicator that a number of times the relationship in the database happen to be true. Okay, so it's like a looping. So we can see that, okay, if there any relationship or not, and okay, how many relationship is happen. So we have to the support and also the confidence. Okay, so later I tell you the like example for this. Okay, and uh, mm, okay, so um, so usually, okay, data mining, okay, used to uncovering relationship among data. Okay, so like example is, okay, so sorry, association rule is a model that identifies specific types of data association. Okay, this association usually used in retail marketing, okay, to identify items that are frequently purchased together. Okay, let's say for those who drink coffee, okay, they also will buy tea. So there's a high association between coffee and tea. Okay, so usually it's used in market basket analysis. Okay, the market analysis. Association are also used in many other applications, like predicting the failure of telecommunication switches. Okay, so let's say that I use a DG now. Okay, so if let's say DG is fails me, okay, I immediately switch to Cellcom. Okay, so there is high association between DG and Cellcom, something like that. Okay, in market basket analysis, okay, the first one of the application is okay to find the association why some items will occur together after a random selection. Okay, like I said that for those who buy coffee, we buy tea. Okay, so there's high association between it. Okay, like in government policy, using the data collected during a census in many nations, the association rule can be used to help the government to come up with sound government policies that will develop democratic society. Okay, they find the association, okay, to in order for help them to build a government policy. In medical, okay, the association rule has been used in making medical diagnosis by identifying probability of any illness occurrence with consideration of symptom and other factors. Okay, this association rule is also used to find the relationship between a new system and an existing disease. So which means that in medical field, okay, so we want to find, okay, what is the association between the symptom and also the illness. Okay, let's say COVID, okay, and the symptoms. Okay, we know that high association for COVID will be coughing, flu, and also prolonged fever. Okay, so and we can also that if relate with COVID, it will relate to influenza. Okay, so it has high association. Okay, and something like that. Okay, so we want to see what is the association between the between the variable. Okay, and next is sequential rule. Okay, it's a sequential rule. Okay, I give another example of association. Yeah. Mm. So then I want to find something that is like simple. Mm. Okay, sorry, it takes time. Okay, but this is all the application. Okay, I will find any like more example. Okay, but usually like in market research, we want to see okay the pattern of behavior or the pattern of the customer behavior. Okay, and also the purchase behavior. What is the association? Okay, in medical usually okay like this the illness and also the symptom. Okay, sequential rule. Okay, the sequential rule is also referred to as sequential pattern mining. Okay, it's technique that helps find patterns that are statistically relevant between the data items. Okay, we want to see is statistically relevant between the data items. Usually, the data values are delivered in a sequential form. One of the assumptions that are made is that the values are discrete. Okay, so we make an assumption that the values are discrete. The sequential pattern is misleading and does not produce accurate data. Okay, because it's not a clustering, it's not a discriminating analysis. So you just like, okay, we just want to find patterns that are statistically relevant between the data item. Okay, then we put a sequence to it. Okay, usually it's not that accurate. Okay, it's not that accurate. We rarely use sequential pattern mining. Okay, so the pattern are based on a time sequence of action. So the pattern are similar to association in the data. Okay, whether it's related, but the relationship is based on time. Okay, so like market basket analysis. Okay, the item that okay because it based on time like in association for the mask association we do a market basket analysis. Okay, we see what is it, we see that some items we buy together. Okay, association of two items, of two items buy together, right? Okay, but in sequential analysis, okay, like also in a market basket analysis in this equation rule, okay, what is the two item? Okay, what is the two item? Is the relationship is based on time. one is based on time. Okay, not based on association. Okay, so this one for sequential, we want to find two items that bought in the same time. It depends on time. Based on time. Okay, so okay, so let's say that CD. Okay, so we want to find, okay, for those who purchase now CD not anymore. Okay, like iTunes. Okay, for those who purchase a song in iTunes, okay, in a sequence analysis, okay, they found that they might buy a song in iTunes after 1 week. After 1 week, okay, so because it based on time, okay, usually, okay, it's not produce the accurate data because it based on time. Okay, but we also needed the sequential rule because, okay, so if we want to look at the variable based on time series, okay, so we need to do the sequential rule. Okay, next is anomaly detection. Okay, what is anomaly detection? It's like outlier detection. Okay, anomaly detection, okay, as outlier detection, concerned with identifying rare items, events, and observation that significantly different from the majority of the data in the data set. So which means that it is totally different. Okay, it's totally different. Okay, so sometimes we call it as noise, outliers, and also exception. Okay, it's totally different. So we must rule out the outliers in order for us to carry out with the analysis. Okay, so the outliers can be categorized into three: contextual and outliers, point and outliers, and collective and outliers. Okay, so what is contextual and anomaly? Okay, so this is anomaly that is shown, okay, when there is a difference in the context of the data item. Okay, so it's already there. Okay, it's already there. Okay, so when there is a difference in the context of the data item. Okay, so when we change the context, okay, it will be outlier. Point anomaly is outliers that is discovered when a data item is far from the data in the data set. Okay, let's say we plot a scatter plot. So all the data is here. Then suddenly there's an outlier here. Okay, so this is an outlier. Okay, so it outs from the data set. Okay, it's out from the data set. Okay, so the first one contextual is, let's say I have a week data. Okay, so the weight data is like 10 kg, 15 kg. Suddenly I have one outlier which is out of context, which is like 15 centimeter. Okay, 15 centimeters. So this one is called the contextual outlier. So which means that this is, okay, out of context. It's not in the same unit because weight should be in kilogram or gram. Okay, third is collectively anomaly. Okay, so it is anomaly that is discovered when the whole data set, when the whole set of data instances is different. Okay, so which means that whole set of data instances is different. Okay, so which means that, okay, let's say I have this data. Okay, suddenly there's an outlier. Okay, like it's collectively. Okay, so it's like a bit here. So this is called a collective outlier. Okay, so it's a bit like out of our data set, like a bit. Okay, not much. Okay, not much. Okay, like okay, call it a collectively outlier. Okay, outlier detection is really done by using the following ways. Okay, first is supervised anomaly detection. Okay, so involve a data set label, okay, containing samples that are both normal and those that contain the anomaly. Okay, this is used to create a predictive model that classifies future data points. Okay, some of the algorithms that used for this purpose include support vector machine learning, okay, by using k-nearest neighbors classifier and also neural network. Okay, in data mining, these two are very like popular in finding the outliers. Okay, first we label the containing sample, okay, mixed with outlier and also the normal one. Okay, then after that, we create a model that classifies the future data point. Okay, so that the one that with the outlier, okay, first it mix together normal and also outlier. Then we create a model. We say that, okay, the predictive model that classify future data point. Okay, so we will know that, okay, this one is outlier. So in next point, okay, it should be like this part is considered as outlier. Usually we use neural network and k-nearest neighbors classifier. That one is supervised. Okay, so we build a model just to find the outlier. Second is unsupervised anomaly detection. Okay, unsupervised anomaly detection. This one does not require any prior training. This method makes two assumptions about the data. Okay. There is only a small amount of data that contain anomalies, and any anomaly in a data set will be statistically different. Okay, the unsupervised, we don't build any model. Okay, we only depend on two assumptions. Oops, sorry. We only depend on two assumptions. Okay, only small amount of outliers exist in our data, and if the outlier is there, it will be different. We can see it visually. Okay, we can see it visually. Okay, so when this assumption in place, a similarity measure is used to cluster data. Okay, and anomalies are defined by the data points that are far from the cluster. Okay, so the like application of anomaly detection, credit card fraud detection, server failure detection, and cyber attack detection. Okay, so which means that okay, so it is far from the cluster. Okay, it is like out of the it's very looks different from the data. Okay, we call it as outlier. Okay, like credit card fraud detection. So which means that if let's say you use the credit card, you are Malaysian, but your credit card has been used in, let's say, China. Okay, so it is outlier. Okay, so usually the data collected that this is Malaysian, so the usage must be within Malaysia only. Okay, like cyber attack detection, same like your email. Okay, it's seen that you log in Brazil. Okay, but you already specify your location currently based in Malaysia. Okay, so that is outlier. Okay, so for application, okay, in data mining, okay, in financial analysis, okay, banking and financial facilities tend to rely on data mining to get high quality data. Okay, so they use the anomaly detection, they use classification, they use regression, okay, and all that. Okay, so it produces information that help the bank predict the loan payment and come up with the credit rating. Okay, this one is by regression. Okay, and maybe by forecasting too. Okay, and also, yeah, classification also help the bank discover the influence of consumers' banking decision. Okay, they also use classification. Okay, other techniques such as the cluster technique help to identify the separate customer with similar loan payment behavior. Okay, like cluster, we want to see the similarity between two, right, variable. So cluster analysis also being used. Okay. Retail industry, okay, the data mining help the organization come up with reliable data on customer. Okay, first, okay, it comes up with the reliable data because of the descriptive model. Okay, we will know the summary of the data. Okay, we will see whether it has the outlier. Okay, and we will see if there's any what is the pattern, okay, of the data, the mean, median, and mode. Okay, so it also helped the organization determine the consumers' purchasing trends and pattern. Okay, this one is by using the association and also regression. Okay, with the recent rise in technology, e-commerce websites have been critical to the success of retail business organization. This has led to the increased use of data warehouse. Warehouse? I think this was a typo here. Use of data warehouse. Cancel it. Okay, data mining helps in the multi-dimensional analysis of the product, customer sales, and other factors. Okay, this is association analysis. So we can see that what is the similarity, okay, between the product preference, the customer preference, and other than that. In biodata analysis, okay, so in data mining, okay, they use in genome research, proteomics research, and also biomedical. Okay, so we use the descriptive association and also regression and plus with the anomaly detection in biodata analysis. Okay, in fraud detection, okay, data mining help providing useful and meaningful patterns. Okay, we can see the mini pattern. Okay, so we have collect the sample record and we use algorithm to search for the way the data is fraudulent. Okay, so we can see that if the data is fraud, okay, there's we use the anomaly detection for that. Okay, and in research analysis, like myself, okay, I was a PhD researcher. Okay, so I use data mining to do the data cleaning, pre-processing, organizing, and also integration into database. Okay, and before I run into any like advanced model or any model, I do data correlation, I do data cleaning, okay, and also I do some summary, data summary to see, okay, the graphical, okay, and to see the everything, okay, I use data mining for that. Okay, data mining in telecommunication field, okay, very important in this industry because it helps in identifying the pattern in telecommunication, ensure that resources are used properly, and help to improve the service quality and make sure the fraudulent activities are caught. Okay, in telecommunication, they also use in fraud, okay, to see the pattern, okay, to make sure that the connection, okay, is done efficiently, efficiently, okay, and like same, we use classification, we use outlier detection, we also use association, and a lot of other data mining techniques. Okay, so I have done with chapter 1.